it might go to like it go to like it's and the IUP.
All right, I'm going to start going through the answers. Please put your desks back where they were. Please put your desks back where they were. I want to make sure you have all the answers.
Yes, sir. Aye, aye, Captain. Here's this. I don't know what's under the desk.
All right. Through the problems, you'll be given 3 different versions of a parabola, right? We've covered all 3 before. If you're talking about standard form, you're talking about y is equal to ax squared plus bx plus c. The other form is in intercept form or factored form, which is y is equal to a times x minus p times x minus q. And then the last form is y is equal to a times x minus h squared plus k. So that is vertex form. To find the axis of symmetry, what you want to do is go through exam H form. The axis of symmetry is given by x is equal to negative b over 2a in standard form. It's given by x is equal to p plus q divided by 2. And on this one, it's just the value of h. X is equal to h. Questions so far? Yes?
What was the y form? That's standard form?
This one right here is standard form. This one over here is intercept form. And this one's in vertex form. You will get all 3 on the test.
Oh, okay.
Once you get the axis of symmetry, you plug that into the function and get the output for the y-coordinate of your vertex. Cool thing about vertex form is that you're given the vertex. Once you find the vertex, find the second point, and then reflect that point across the axis of symmetry, and now you've got 3 points. You might be good to move on. All right. So, label the vertex with a point and the axis of symmetry with a dashed line for each parabola, and then sketch the graph. Number 1, you've got this in standard form. The parabola is going to open downward because the value of a is less than 0. So now you want to find the axis of symmetry, which is given by negative b over 2a. In this case, you're going to plug in negative 2 in for b, and then divide that by 2 times negative 1. The opposite of negative 2 is 2. 2 divided by 2 times negative 1, and you're going to get negative 1. So there is your axis of symmetry. You draw a dashed line, like they say. Once you have the axis of symmetry, you're going to plug that into, all right, your original function. So now you're going to get y is equal to the opposite of negative 1 squared minus 2 times negative 1 plus 1. And if you simplify all that, you're going to get 2. So this is telling you that the vertex is the point negative 1, 2. You can construct an xy table for this. There's negative 1, there's 2. That's your vertex. 0 is very nice to work with in this problem. You can easily get the y-intercept. If you set x equal to 0, it's going to be the constant right there, which is 1. So you know that 0, 1 is going to be part of the parabola as well, a point lying on the parabola. And then all you got to do now is reflect the point 0, 1 across the axis of symmetry, in which case you land at the point negative 2, 1. The parabola does open downward, and we're drawing a parabola that does open downward, so we're doing this correctly. Make sure you connect the points with a smooth curve on both sides, and then arrows at both ends. So there is standard form. Number 2, this is an intercept form. In this case, the value of 1 is 1, so you know that A is greater than 0. The parabola opens upward. You can easily get the x-intercepts if you set your factor is equal to 0 using the zero product property. You're going to get x minus 4 is equal to 0, x minus 2 is equal to 0. In both cases, when x is 4 and x is 2, the value of y is 0. So you are going through the points 2, 0, and 4, 0. The axis of symmetry lies directly between those 2 points. Which is x is equal to 3. If you just want to double check, you can. You can take your x-intercepts and add those together and divide by 2. And you're still going to get 3. Since you know that 3, all right, is going to be the x-coordinate of your vertex, you can plug in 3 into the original function and get y. So y is equal to 3 minus 4 times 3 minus 2. 3 minus 4 is negative 1. And then 3 minus 2 is 1. Negative 1 times 1 is negative 1. So when x is 3, the value of y is negative 1. You can plot that point, and then connect your dots. Again, draw this with a smooth curve, and then arrows on both ends. Are we good with that one? All right. Number 3 is in vertex form. So in this case, the vertex is given by the ordered pair 3, 4. Be very careful of the signs, all right? You want to think opposite of the signs inside the parentheses. If that was 1/4 times x plus 3 squared plus 4, you would take the opposite of a positive 3 and make that negative 3. So the vertex is 3, 4. Your axis of symmetry is going to go through the vertex. So now we have x equals 3 as your axis of symmetry. The parabola will open upward. We do need another point. Just for the heck of it, we could plug in 5 for x and see what happens. If you take 5 minus 3, you get 2. 2 squared is 4. You get 1/4 times 4 plus 4, and you get 5. So just doing the xy table. Again, the vertex is 3, 4. You plugged in 5 for x and got y being 5. So there is 5, 5 right there. And then all you got to do is reflect that point across your axis of symmetry, in which case you know that y is going to be 5, and the value of x is going to be 1. And then again, connect those with a smooth curve. All right. So we label the axis of symmetry, we've got the vertex, the parabola opens upward, we're good there. Am I good to move on? All right. For problem number 4, you've got to write an equation of a parabola in standard form, giving the following information. The parabola has a vertex of 4, -3, and passes to point 1, 2. You know that vertex form of parabola is given by y is equal to a times x minus h squared plus k. Essentially, you have everything but the value of a. So the vertex of the parabola is 4, -3. We're going to the point 1, 2. So plug in 2 for y, and then set that equal to a times 1, because this is xy. And then you're going to take minus h, which is 4 squared, plus -3, or just -3. So here's your hk. Again, the only thing we do not know is the value of a. We can solve for that. Now we get 2 is equal to 1 minus 4, which is -3. -3 squared is 9. We could rewrite this 9 times a minus 3. And now we got to solve for a. You can add 3 to both sides of your equation and get 5 is equal to 9 times a. Divide both sides by 9 so that the value of a is 5/9. So in intercept form, or in vertex form, you get y is equal to 5/9 times x minus 4 squared minus 3. For a problem like this, though, they're asking it to be in standard form. So here we do have to FOIL everything out. Practice those algebra skills. You get y is equal to 5/9. And then x minus 4 times x minus 4 is x minus 4 squared. Minus 3. If you were to FOIL this one out and combine like terms, you would get 5/9. And then you would get x squared minus 8x plus 16 minus 3. All I did there was FOIL everything out and combine the inner and outer, outer and inner terms. Negative 4x minus 4x, negative 8x. Next, you go through and distribute your 5/9. So in this case, you're going to get 5/9 x squared minus 40/9 x plus 80 over 9 minus 3. You can combine the constants together. Here you've got 80 over 9. The common denominator in this case would be 9, right? So we got to multiply top and bottom by 9, not by 3. So in this case, you'd finally get 5/9 x squared minus 49x plus 80 minus 27, and how much is that? 53? 53/9. So there it is in standard form. A is 5/9, B is negative 40 over 9, and then C is 53 over 9. Yes, Madison?
That 9 up there from the last equation, is that a 3 or a 9, did you say?
This right here?
Yeah.
This one right here?
No.
This here?
Yeah.
Oh, the common denominator is 9. I accidentally put a 3 right there. I think 3 times 3 is 9, which it is. But I need 1 times 9, so I need to multiply the top and bottom of negative 3 over 1 by 9 to combine those two together.
Oh.
You could also plug that in a calculator and get the answer. Other questions? All right. Factor each completely. So here we're not solving, we're just factoring. So you want to find factors of 48, whose sum is negative 14. Yep, negative 6, negative 8. Again, you're not solving for anything, so just rewrite x minus 6 times x minus 8. For number 6, you want to find factors of 50 whose sum is 15. 10 and 5. 10 times 5 is 50. 10 plus 5 is 15. So this will factor into p plus 10 times p plus 5. For number 7, you can factor out the greatest common factor. In this case, it's going to be n. So take n times the quantity of n plus 3. When you factor out an n, that's the same thing as dividing everything by n. N squared divided by n is n. 3n divided by n is 3. So now we get n times the quantity of n plus 3. Great. We want to find factors of negative 9, whose sum is negative 8. In this case, we're going to get negative 1 and a positive, or sorry, negative 9, positive 1, right? Negative 1 times, or negative 9 times 1 is negative 9. Negative 9 plus 1 is negative 8. So this will factor into a minus 9 times a plus 1. You will get a difference of squares on the problem, so that's what number 9 is. Difference of squares formula is a squared minus b squared is equal to a minus b times a plus b. 1 is a perfect square number, so you have b squared minus 1 squared. You get b minus 1 times b plus 1. For the next one, factor each completely. Remember to try to figure out what the greatest common factor is. So try this. Try first, factor GCF, greatest common factor. So for number 10, you can factor out 6. Everything is divisible by 6. When you factor out a 6, that's going to create the expression 6 times x squared plus 13x plus 30. And now we can find factors of 30, whose sum is 13. Those are 10 and 3. So now you get 6 times the quantity of x plus 10 times the quantity of x plus 3. If we didn't factor out the greatest common factor, we would take 6 times 180, get a large number, try to figure out what factors of those whose sum is 78. Please do not do this. Do try to figure out what the greatest common factor is first, if possible. Yes, Katie?
Oh, never mind. I answered my question.
Okay. Number 11, if you look at 3b squared plus 38b plus 80. This does not have a greatest common factor, so here we do have to go through, take 3 times 80, and get 240. To factor this using group factoring, we want to find factors of 240, whose sum is 38. Such factors are 30 and 8. Times 8 is 240. 30 plus 8 is 38. So rewriting this expression, you're going to get 3b squared plus 30b plus 8b plus 80. You then want to go through and group factor. So group the first two, and then group the last two. The greatest common factor of 3b squared plus 30b, factor out 3b. We now get b plus 10, and then we can factor out 8 from the other quantity, and get 8 times the quantity of b plus 10. Those are the same binomial linear factor, b plus 10. You can factor those out and get b plus 10, a quantity times a quantity of 3b plus 8. If you do see the factors in your head and write down the factors, I will allow this, all right? If you're that good factoring these. Questions about group factoring so far? All right, we might get to move on to number 12. Another one of group factoring. In this case, you've got 5n squared minus 41n plus 42. So again, you want to go through and see if there's a greatest common factor and factor out. There's none. Yep, take 5 times 42, which is 210. We need to find factors of 210 whose sum is negative 41. Both have to be negative, yep. We've got a negative followed by a positive. In this case, factors of 210, I see 30 and 7, but that's not going to help us out. You could go through and list the factors. I believe negative 35 and 6 works. Negative 35 times negative 6. Yep, we get 210. Negative 35 plus negative 6. There's your negative 41. So now we get 5n squared minus 35n minus 6n plus 42. When you group factor, be very careful of the negative sign. You now get 5n squared minus 35n, and then parentheses minus, and don't forget to change the sign of positive 42 to a negative 42. So now I get 5n squared minus 35n as a quantity minus the quantity of 6n minus 42. Here we can factor out of 5n and get n minus 7. And then on the second one, we can factor out 6 and get n minus 7. And now we have the same binomial linear factor, n minus 7. Factor out 1n minus 7. And now we get n minus 7 times the quantity of 5n minus 6. Again, if you see the factors and know how to factor it, all right? That's fine. If you don't see the factors, you can group factor. Yes, ma'am?
Why did you change plus 42 to minus 42?
Because if you redistribute the minus sign, you should get the original expression back. Negative 1 times 6n is negative 6n. Negative 1 times negative 42 is a positive 42. Other questions? All right. Solve each by factoring. You'll get some that are already in factored form. So this one, just set your factors equal to 0. In which case we have p is equal to 4 or p is equal to negative 8. If the coefficients in front of those are 1, you can think the opposite. All right, and do that in your head, that's fine. 14, we do not have coefficients of 1 for both, so here we do have to do a little work. Set 4x minus 1 equal to 0, and then x minus 4 equal to 0. In the case of the first factor, 4x minus 1 equals 0, you would add 1 to both sides, divide by 4, and get 1/4. And then for the other one, just add 4, you get x is equal to 4. So those were already factored. Just set those equal to 0 and solve for your variable. The others, though, are not factored yet, so we have to factor them. So here we can factor out n, get n times the quantity of n plus 3 is equal to 0, and then set your factors equal to 0. N is equal to 0, or n plus 3 is equal to 0. N equals 0 is already solved. For the other one, you got to subtract 3 to both sides, and you'll get n is equal to 0, or n is equal to negative 3. For these, remember you can plug them back in and see if they work. If you factor them correctly, you don't have to go back and check, but if you have time on the test, you can go back and check. Here you need to find factors of 32, whose sum is negative 12. In this case, we're going to get negative 4 and negative 8. So now we get x minus 8 as a quantity times the quantity of x minus 4 is equal to 0. In the case of this one, you can think the opposite and get x is equal to 8 or x is equal to 4. with those. Next. Solve each equation by taking square roots. The final answers must be in simplest radical form. So in this one, you can subtract 2 to both sides of your equation. You now get negative 8n squared is equal to negative 256. You then want to go through and divide both sides by negative 8. You now have n squared is equal to, I believe we get 32 off of this. When you take the square root to both sides, bear in mind there are 2 solutions, so don't forget your plus or minus signs. You now take the square root to both sides. So if you simplify that, you get n is equal to plus or minus. And then root 32 is the same thing as root 16 times root 2. So now we get n is equal to plus or minus 4 root 2. Same deal with number 18. You want to get n by itself, so get n squared by itself, add 3 to both sides. In which case you now get 64n squared is equal to a positive 1. Divide both sides by 64. So now we get n squared is equal to 1 over 64. To want to do the square root both sides of your equation. And now you get the square roots of n squared is equal to plus or minus the square roots of 1 over 64. Here you can use the quotient property square roots. So n is equal to plus or minus root 1 divided by root 64. If the denominator is a perfect square number that you're taking the square root of, you do not have to rationalize the denominator. It will come out evenly. So here we get n is equal to plus or minus 1/8. For number 19, you will get imaginary numbers. So in this case, you can subtract 3 to both sides and get 6n squared is equal to negative 44. Divide both sides by 6. Now you have n squared is equal to negative 44 over 6. Just simplifying this a little bit, 2 goes into 44 22 times, and then 2 goes into 6 3 times. So simplifying this, you now have n squared is equal to negative 22 thirds. You then take the square root to both sides. So now we get n is equal to, don't forget my plus or minus signs, plus or minus the square root of negative 22 divided by root 3. This one you have to rationalize the denominator, so you can multiply the top and bottom by the square root of 3. So now you get plus or minus the square root of negative 66 divided by 3. Remember, your radicals have to be in simplest form, so when you take the square root of a negative number, you got to simplify it further. Using the product property square roots, you get plus or minus the square root of negative 1 times the square root of 66 divided by 3. I don't know why I put 33 there. Let me erase that. Remember that the square root of negative 1 is I, so you get plus or minus I times root 66 divided by 3. Root 66 is the product of 2 prime numbers, 3 and 11. So here you can now simplify root 66. Are we good here? All right. Moving on to 20. For 20, they want you to solve this by completing the square. Final answers must be in simplest radical form. So to accomplish this, you want to get all your x terms on one side, add 66 to both sides of the equation. You now get x squared minus 6x, and leave yourself some space, is equal to 75. To complete the square, identify your b term. In this case, it's negative 6. So add negative 6, divide that by 2, and then square that to both sides of your equation. Simplifying that, you now get x squared minus 6x plus negative 3 squared is equal to 75 plus 9, which in this case is 84. Factoring your perfect square trinomial now, after completing the square, you get x minus 3 squared, and that's equal to 75 plus 9, which is 84. You can now take the square root to both sides of the equation. And again, please do not forget your plus or minus signs. You then want to take the square root of 84, in which case you get 2 root 21. Add 3 to both sides of your equation, and you get the two solutions. X is equal to 3 plus or minus 2 times the square roots of 21. That does it for completing the square. Moving on to the imaginary numbers. Simplify. Final answers must be in the form a plus bi. So in these, don't forget that I squared is equal to negative 1, since the square root of negative 1 is equal to I. Here you're just combining like terms, so take that 4, add 4, get 8. Negative I minus 2i is a negative 3i. And you're done. Again, make sure that you have the real part first and the imaginary part last. The next one, you got to distribute a minus sign. So here you get 4i minus 2i minus 5 plus 7i. Again, you're using the law of distribution, distribute the negative 1. Combining like terms. Real part first, so you've got negative 5. Combining like terms, you got 4i minus 2i, which is 2i, 2i plus 7i, which is 9i. Be very careful with 23. You have a binomial you are squaring. So in this case, just rewrite this negative 7 plus 3i as a quantity, and then negative 7 plus 3i as a quantity. And then go through and use the FOIL method. Take the first, outer, inner, and then last. Negative 7 times negative 7 is 49. Negative 7 times 3i is negative 21i. 3i times negative 7 is another negative 21i. And then 3i times 3i, in this case you're going to get a positive 3i squared. Remember that I squared is equal to negative 1. Do combine your like terms, you get 49 minus 42i plus 3. Actually, isn't that 3? That's 9, my bad. 3i times 3i is 9i squared. So we should get now 9 times negative 1. That's better. Combining this, you've got 49 plus 9 times negative 1. You're going to get 40 minus 42i. Again, real part first, imaginary part last. 24, you have to get rid of the imaginary number from the denominator. So here we'll multiply by the complex conjugate, 3 minus I, to the top and bottom. Go through and FOIL this out. 3 times 3 is 9. 3 times I is negative 3i. And then I times 3 is a positive 3i. And then I times negative I is negative I squared. On the top, you're going to distribute your I, and then get 3i minus I squared. When you're foiling this out with a complex conjugate, the outer inner terms are going to cancel out in the denominator. Replacing negative 1 in for I squared, you now get 3i minus negative 1 divided by 9 minus negative 1. Combine these together, you do get 3i plus 1 divided by 10. Don't forget to get the imaginary parts and the real parts separated. You can now rewrite this 3i divided by 10 plus 1/10. The common denominator is 10. And then make sure you have the imaginary part last, so rewrite this 1/10 plus 3/10 times the imaginary unit I. The last two problems with your imaginary numbers are to graph these and find its absolute value. So if you have the absolute value of, let's say, a plus bi, that's the same thing as the square root of a squared plus b squared. So in this case, you rewrite 25 the same thing as the absolute value of 2 plus negative 3i. In which case, its absolute value is going to be the square root of 2 squared plus negative 3 squared. And if you simplify that, you're going to get the square root of 13. They do want you to graph this, so 2 minus 3i, start at the origin, go 2 units to the right, and then 3 down. So there's 2 minus 3i. The distance from the origin to the point would be root 13 units away. 426. The absolute value of this one is just the square roots of 3 squared plus 3 squared, in which case you get the square root of 18. And if you simplify that, you're going to get root 9 times root 2, or 3 root 2. So apply this one, again going 3 units to the right, starting from the origin, and then 3 up. And there is 3 plus 3i. All right, are we good with imaginary numbers? Moving on to the last parts. Solve each equation with the quadratic formula. Final answers must be in simplest radical form. So for 27, we've got 2n squared plus 4n plus 7 equals 0. When you're using the quadratic formula, make sure everything's in the form ax squared plus bx plus c is equal to 0. And the quadratic formula is given by x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So in the case of this one, a is 2, b is 4, and then c is 7. So n, in this case, is equal to negative 4 plus or minus the square root of 4 squared minus 4 times 2 times 7. And that's all divided by 2 times 2. So if you simplify this, you're going to get negative 4 plus or minus the square root of some negative number divided by 4. And the square root, let's see here, we get 16 minus 4 times 2 is 8, 56. Looks like we get negative 40.
Yep.
So we can simplify the square root of negative 40. I'm just going to do some scratch work over here. You can take the square roots of negative 1 times the square root of 4 times the square root of 10. And now get I times 2 times root 10, or 2I times root 10. So now we get negative 4 plus or minus 2I times root 10 divided by 4. Do simplify these. So 2 goes into 2 twice, 2 goes into 2 once, and then 2 goes into 4 twice. So now you get as a final answer negative 2 plus or minus 1I times root 10 divided by 2. On this one, I will allow you to leave the imaginary numbers inside or right in front of the radicals, and you don't have to write those as two separate answers. For 28, it is written in standard form. A is 5, B is negative 1, and C is negative 6 for negative 76. So now we get A is equal to negative of negative 1, since we have a negative 1 coefficient right there, plus or minus the square roots of negative 1 squared minus 4 times 5 times negative 76, all divided by 2 times 5. We do need to simplify what's underneath the square root. We get 1521. So 1 plus or minus root 1521 divided by 10. The square root of 1521 is a perfect square number. Yep, 39. Do make sure you simplify this, right? Take 1 plus 39 over 10, or 1 minus 39 over 10.
X equals 4 or x equals negative 19 over 5.
And there we go. All right. Number 29. This one is not written in standard form, so subtract 12m to both sides. You now get 5m squared minus 12m plus 1 is equal to 0. And then putting this into quadratic formula, you get m is equal to the opposite of negative 12 plus or minus the square roots of negative 12 squared minus 4 times 5 times 1, all divided by 2 times 5. Let's see what we get for the radicand. You would take negative 12 squared is 144 minus 4 times 5 and get 20. We do get 124 for that. So we get 12 plus or minus the square root of 124 divided by 10. Root 124 is the same thing as 2 root 31 divided by 10. Do simplify this. 2 is divisible by all those numbers. 2 goes into 12 6 times. 2 goes into 2 once. And then 2 goes into 6 5 times. Or sorry, 2 goes into 10 5 times. So as your final answer, you now get 6 plus or minus root 31 divided by 5. And root 31 cannot be simplified. All right, there's the quadratic formula. The next 6 problems involve using the discriminant of your quadratic equation. Your discriminant is given by b squared minus 4 times a times c. So in this case, we could add 6 to both sides of the equation. Make sure this is in standard form. You get negative 6m squared plus 5m minus 7 is equal to 0. So the discriminant in this case is going to be 5 squared minus 4 times negative 6 times negative 7. If you multiply that out, you do get negative 143. Since that is less than 0, there are two imaginary solutions.
So what do you want that to do? You want that less than 0 sign
Nope. If you want to leave the less than 0 sign out, you can.
or? Alright.
Just know that if you get a negative number for the discriminant, two imaginary solutions. I'm just going to give out the answers to the rest. All right. For 31, if you were to use the discriminant, you get negative 36. So here you have two imaginary solutions. For 32, the discriminant is 0. So there's only one real solution. For 33, the discriminant is 16. 16 is greater than 0, so there are two real solutions. For 34, the discriminant is 0, so there's only one real solution. And then for 35, if you get the discriminant for that, it is 1. 1 is greater than 0, so there are two real solutions for that one. Are we good to move on to the application problems? All right.
You're a little slow today.
It is. All right, a basketball is shot with initial velocity of 24 feet per second from 6 feet above the ground. So in this case, if you set up the equation first in physics, you get y is equal to negative 16 t squared plus 24t plus 6. When does the ball reach its maximum height? Well, if you draw a graph of this, we're shooting at a height 6 feet from the ground. The x-axis is the time. So we want to find the vertex. When does the ball reach the maximum height? So we're looking for a time. T is equal to negative b over 2a. So in this case, you're going to take negative 24 and divide that by 2 times negative 16, in which case you get 0.75 seconds. What is the maximum height? Plug in 0.75 in part A into the equation. You get y is equal to negative 16 times 0.75 squared plus 24 times 0.75 plus 6, and you're going to get 15 feet. And then for the part, how long is the ball in the air? You want to find the x-intercept, so you're going to set y equal to 0 and solve for t. So in this case, you're going to get 0 is equal to negative 16 times t squared plus 24t plus 6. Using the quadratic formula, because this one you cannot factor, you're going to get t is equal to the opposite of 24 plus or minus the square roots of 24 squared minus 4 times a, which is negative 16, times c, which is 6, all divided by 2 times negative 16. If you were to simplify this, you're going to get negative 24 plus or minus 8 times the square root of 15 divided by negative 32. You will get two solutions, one real solution that's positive, one real solution which is negative, and you want the positive solution, all right? So doing this, you plug in negative 24 plus 8 root 15, divide that by negative 32. You're going to get the negative solution, negative 0.218. And then for the other one, negative 24 minus 8 root 15 divided by negative 32. And you're going to get 1.72 seconds. So you do want the positive solution. The ball is in the air for 1.72 seconds. Are we good here? All right, 2 more problems to go. We'll be done. The height, y in feet, of a ball thrown by a child is given by y is equal to negative 1/12x squared plus 2x plus 4, where x is a horizontal distance in feet from the point at which the ball is thrown. So here's your horizontal distance, and then here's the vertical distance, how high. When x is equal to 0, when the horizontal distance is 0, the vertical distance is 4. So how high is the ball when it leaves the child's hand? 4 feet. Next, you want to find the maximum height of the ball. So in this case, you got to find the horizontal distance first. And you can calculate that by finding the x-coordinate of the vertex. So x is equal to negative b over 2a. In this case, it's going to be the opposite of 2 divided by 2 times negative 1/12. And if you solve for that, you get 12 feet. So when the ball is thrown out, its horizontal distance traveled, all right, 12 feet to get to the highest point. But now we got to get the highest point. So now we plug in 12 into the original function and get y is equal to negative 1/12 times 12 squared plus 2 times 12 plus 4. And if you solve for that, you get 16. So what is the maximum height of the ball? It will be 16 feet. All right. How far from the child does the ball strike the ground? You can use the quadratic formula and solve for the x-intercepts. Set your function equal to 0. You get 0 is equal to negative 1/12 x squared plus 2x plus 4. If you're using the quadratic formula for this one, I'd greatly recommend that you try to have the leading coefficient equal to 1. So go through and multiply everything by negative 12, and this will alleviate that problem. Negative 12 times 0 is 0. Negative 12 times negative 1/12 is 1, but that's an x squared. Minus 24x minus 48. Use the quadratic formula, and now you get x is equal to negative 24 plus or minus the square roots of negative 24 squared minus 4 times 1 times c, which is negative 48, and then divide that by 2a, or 2 times 1. If you solve for this, you'll get 2 solutions. I'm just going to give you the 2 solutions. One solution will be 25.86 feet, or negative 1.86 feet. In this particular case, you do want the positive solution, 25.86 feet. All right. Am I going to move on to the very last problem now? All right. A rectangular garden is 225 square meters. The length of the garden is 2 less than 3 times the width. Find the dimensions. I would draw a rectangle like this. You don't know what the width is, but the length is going to be 2 less than 3 times the width. So let's make that 3w minus 2. The width is w. To find the area of a rectangle, you take the width times the length. So you take 3w minus 2 times w, and then set that equal to 225. Go through and multiply everything by w. You now get 3w squared minus 2w, which is equal to 225. And then get 3w squared minus 2w minus 225 is equal to 0.
You can solve by completing the square.
You can also solve by completing the square using the quadratic formula. Hang on just 1 second, I'll give you the solution. I believe w is 9, but I'll double check that.
And now for a homework quiz?
Yep. So if you solve this, w will be equal to 9, the positive solution. There will be 1 negative solution. So the dimensions are going to be 9 by 25 feet. So that is your test. Good luck.